Okay, my name is Magnus Wharton and I'm getting bored shitless, so I decided to go talk about my robot design. Here it is. So put me in the little corner. Oh, there's a light. Anyway, so here's my robot design, the NIGKIL 5000. And I don't know what to say. Those little canisters coming out of you look like grenade launchers, but they're actually canisters to put coils in for the motors. And it's got roll pitch yaw on every single joint, so it's a bit like a tentacle monster. It can actually flip 180 degrees and stand upside down, just the same way as it did the other way around, except its canisters go the other side of it, go down instead of up. Inside this central box here, where his body is, there is a computer, a battery, and a sensor. The sensor will be a microphone and an emitter, and I'm going to produce a 3D map from it. So the sensor goes into the computer, and the computer spits out the motor positions for every single 36 of the Ds. And I like the legs are pretty cool. I liked how they turned up, but there's nothing non-functional there. But it looks kind of cool. The only non-functional thing is it whacks itself if it turns too far. But that's why on the X I've got two small radius motors instead of one big one. There's two big fatties and the X pitch is handled by two small radius motors in parallel, or just working together. The circuit which controls the motors is a little dodgy, and I've got an example of it over here. This linear drive, I wish I could show you it working, but I just ran out of batteries. But I can do it with my fingers. Yes, this spool pulls it left, and this spool pulls it right. And this circuit, what's on the back, is what's going to go on the motors. It's an approximate absolute positioning system. So here's the back. So these grey wires in the middle, they go to a diode each to separate the positives from each other, and they all get a negative. Then there's one reducting wire, the blue one, it's one additive wire, it's the red one, but it's not doing a subtract or an add, it's doing a divide, so it's slightly different. And I haven't got it working yet, but there's actually a dead spot. If it goes too close, if the target's too close to the motor, it won't turn it, so it'll tend to lag behind it, but I can correct for that, and I just lose a bit of angular freedom. But I wonder if that actually doesn't matter so much. No, it does. So I lose a bit of angular freedom. But I wish I could show you that thing working, but it's not working at the moment. Anyhow, but I can draw the circuit for it. So there's another shot of the little robot. Then, for every motor, they all get a positive. So but they're on the positive, there is there's a diode on going like that, and that stops these negatives from going up it. Yeah. And so what basically is like that's the current position of the motor in a form of resistance. So we're going to use a potentiometer, and this is the target position. And the current going down the wire is this one would be CP divided by TP, and this one would be TP divided by CP. So in other words, we put the motor on this one, and when the target position is further enough behind the current position, or further enough in front, I mean, then the motor will turn. But like you said, it creates a dead spot. So if they're within a certain range of the target position, then it'll stop short. And so we'll have to correct for that with a bit of like just changing the resistances. You can make it so that fixes itself. And so just every just imagine if there's every motor, then it's just the same, and you see the diode coming out of every one. That can be a resistor, but it won't be as good. And so that's that down. I just got to prove that's fucking true, and it's like a voltage divider. And if you use a voltage divider to control a motor, it's a kind of an approximate type sort of thing. So it's like using a voltage divider as a comparator. And the other problem is, because there's two channels for the voltage to go down, there's waste that's always going down the reductive side. And I suggest what I'm going to do is I'm going to get all those negatives and I'm going to hook them up to a capacitor, and I'm going to charge a capacitor, and then I'm going to put an alternator on the computer that's going to change between two different capacitors. So it has two circuits, and one uses it, the other one's capacitor, so that means I don't waste the current. And I've got to set that up yet. And then if I do that, then it's not looking too bad. Probably should work. But I need those diodes could be resistors, but probably best to have them as diodes. So I'm thinking about making my own diodes for it. There's about one diode per D on it, so there's about 36 diodes lined up. And I could use razor blades, and toasting razor blades, they probably have a bit of back loss on them, homemade diodes, but I bet it will be better than just using even a professional resistor. It'll still do a better job. So because you can make diodes, it's probably not so bad. It's a pity that it needed them. I wanted to do it without a single component. And you can see how simple this circuit is. It's my introduction to electronics. So I wanted to see what can I do without just instantly going to op amps without understanding them. I decided, like, what if I used the base primitives? And I think in a voltage divider situation that you can actually have a go at making a motor comparator. You know. See, oh yes, inside there's the computer. That's half a secret, but what the method that the computer is actually running is totally a secret. I'm not going to tell anyone that. But let me tell you, it's going to be pretty amazing. We're going to do we're going to max. It's going to slowly build a model into the eye, and we're going to get the peak result from the model every fucking millisecond. It's going to have a huge frequency. It's going to have a huge frame rate, this thing will have. And it's going to have a very big store. Like, it's never going to forget. So the model it's building is going to grow, slowly grow. Yep. And it never empties. It just constantly grows. It won't need to forget for a year, hopefully. So basically we're taking in patterns, and then we find the optimal result from the patterns every frame. I'm not going to, that's what I'm doing, but I'm not going to tell you how I do it. And so this is going to be killer.